In this lesson, we're going to continue our examination of patterns. Yesterday we looked at an arithmetic sequence. We're going to extend that today to an arithmetic series. So yesterday we had this idea of a pattern, right? A constant difference between terms. So we go from 1 to 3 to 5 to 7, our difference is 2. Well, if we take those same terms and we start adding them together, so 1 plus 3, 1 plus 5, plus 7, so on and so on, we call that a series. Again, there's still a constant difference. But today, instead of looking at the pattern itself, we want to figure out what the pattern adds up to. Okay, to find the sum, to add them all together, we don't actually have to punch in our calculator 1 plus 3 plus 5 plus 7 plus so on, so on, so on. We have ourselves an equation. Today we're going to use the equation Sn. It means the sum of n terms. So how many terms do we have? Let's add them all together. And then beyond that, we have a lot of the same letters we had yesterday. So A is our initial value, our starting point, N is how many terms we have, and D is our common difference. So no new things there. In fact, if you were to cover up the 2, this piece inside should look familiar. Right? It's the same thing we had yesterday. We talked about a sequence. So we'll try one. Okay, I want to find S20 for the sequence given by this pattern here. In other words, I want the sum of the first 20 terms. So my equation, S20 is, this is n, so 20 divided by 2, 20 terms. 2 times A is our first term, plus n again, so 20 minus 1, and D is our difference. And we're going down by 6 each time, so we use a negative 6. And we're going to do 3 sets of math. 20 divided by 2 is 10, 2 times 7 is 14, and in the bracket, 19 times negative 6 will give us negative 114. Okay, so I usually do 3 things at once. So this one, and all of that. And that leaves us with 10 times negative 100, which is, oops, not 100. Fix that. Which is negative 1,000. So if we were to type in our calculator 7 plus 1 minus 5 minus 11 minus 17 minus 23 and so on and so on and so on, for the first 20 terms, it would come up to the negative 1,000. This just does it a whole lot faster for us. Let's try another one. Find the sum of the sequence defined by 7 plus 14 plus 21 plus dot 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 plus 175. So this question is different from the previous question in that we're not told how many terms we have. We've got to figure that out first. So whenever we want to figure out how many terms we have in a sequence, we have to go back to yesterday's idea to figure out the terms. I know my starting value is 7. I know my difference every time is going up by 7. And I actually know a term in the sequence, in particular, the last term. So if I can figure out what term number that is, I can solve for how many terms. So 175 for our t, 7 is our a value. I don't know how many terms we have. My difference happens to be 7. I can solve this equation. So we'll expand our brackets. So I'll multiply. I'll collect like terms, and in fact these two 7s will cancel each other out. So I get that. And n will be, what's that, 25? Okay, now that I know there's 25 terms, I can go back to my new equation, my sum. So the sum of 25 terms will be 25 divided by 2. Our first term was 7. We just said there's 25 terms, and my difference was 7. Okay, math in 3 spots. 12.5, 14, and 24 times 7 would be 168. So I get 12.5 times 182, and that gives me 2,275. Okay, we can only use the S equation if we know all the parts and pieces, the N, the A, and the D. If we ever need to solve those, we generally go back to the sequence equation that talks about the pattern. Now, there is a bit of a shortcut. Okay, if we were to look closely at the equation we just developed, there's some equation, you might notice, as I said earlier, something looks kind of familiar. I would hope that you could agree that we could break 2a into an a plus an a. And if I write this part exactly the same, we said that this looks familiar. That's our sequence equation, the one we learned about yesterday. So there's a bit of a shortcut. I can rewrite this box as just Tn. A stayed the same, n over 2 stayed the same. So that tells me that if I know the first term, term number 1, a, and I know the last term, Tn, I can use this little shortcut to figure out the sum of the sequence. If we look at the one we just did, and for example, the one we just did was 7 was our first term, 175 was our last term, and we figured out that there was 25 terms. We have to figure out how many terms are first. There's no choice on that. Okay? But if we say that, if we say that there's 25 terms, we figure that out. And we take 25 divided by 2, and we multiply by 7, that's our first term, and 175 was our last term. So A and Tn, we'll get 12.5 times, hey, 182. We've seen that number already, right? That was what we had when we did the long way. 182 right here. This just saves us that work. And it's a bit of a shortcut. But as I said, we still have to figure out what n is. It just saves us from using the big long equation. Okay, so you guys give one of those a try. So I'm giving you the first term, I'm giving you the last term, I'm giving you the difference. Can you figure out what this sequence adds up to? Oh, I need to know how many terms there are. So I need to go back to my t equation. I know the last term is 4,374. Our first one's 2. I don't know how many, but our difference is 4. Let's expand our brackets. We'll collect some like terms and rearrange this equation. And we'll get 4,376 is 4n. If we divide that by 4, we get 1,094. That's a big sequence. I won't want to punch on my calculator. But if I want to figure out the sum of it, I can do that pretty quick. Divide by 2, and using our shortcut, first term is 2, last term is 4,374. So we get 547 if we divide by 2, in the bracket 4,376. And just using that little shortcut and our sum, big number here, 2,393,672. Okay, let's try something a little different, some problem solving. A theater has 20 seats in the first row, 21 in the second row, 22 in the third row, and so on and so on. The theater has 40 seats in the last row. How many seats do we have altogether? Well, if we were to write that out, we would see that we've created ourselves a sequence. I don't know how many rows are in that sequence or terms are in that sequence, but I can solve that using my Tn equation. So my term number at the end, I want to figure out what the 40th term, or what term comes out to 40. And my n, don't know it. My different, I'm going up by 1 each time. That makes life easy. So we'll get 40 minus 20 plus 1. It's basically the same kind of question we just did a second ago. So there are 21 rows in the theater. How many seats are there? Well, let's figure out the sum of 21 rows. First term was 20, last term was 40. So we'll get 10.5 times 60, or in other words, 630 seats. And that saves us from counting each row and then adding them together, right? This pattern idea. Okay, last one. Some simple ones today. So we got Michelle. She's a marine biologist. She accepted a job that pays her $46,850 in the first year and $56,650 in the 8th year. Her salary is an arithmetic sequence with 8 terms. What raise can she expect each year? So what do we know? We know that the A value is 46,850. We know that term number 8 is 56,650. We're asking what raise can she expect? In other words, what's the difference in the pattern? That's our D value. We can solve that by using, we're thinking about the sequence itself here, the Tn equation. Term number 8 is 56,650. Term number 1, 46,850. We know n is 8. All I'm missing is d. We can solve that. So set up our equation. Got 7d on that side now. If we subtract, we get 9,800 is 7d. And if we divide by 7d, is 1,400. There's her raise, her difference in each year. What will her salary be in the 6th year? So again, we're looking at terms of the sequence. So we're asking for term number 6, the 6th year. And so go back to the beginning. What did we say our A value was? 46,850 plus n is 6 now. Our difference we just calculated was 1,400. And we'll punch that into our calculator there. Or if you want to show steps, you can do that. You don't need to show me the intermediate step if you don't want to. You can go right into your calculator. We get 53,850. Okay, part C. In what year will her salary first exceed 50,000? In other words, where in the sequence is that value? So back to our sequence. Using our Tn equation still, I want to know when do I hit 50,000? N minus 1 times d. We easily figured out our d. Okay, we got to solve this equation. So 50,000 minus 46,850 equals, we're going to expand this, 1,400n minus 1,400. I can do some more rearranging here. So 50,000, 46,850 plus 1,400 equals 1,400n. If we collect all those terms, we get 4,550 and 1,400n. So n is 3.25, which is between terms. It's between the 3rd and 4th terms. So when does she actually exceed 50,000? Should in the 4th year. At the 3rd year, she hasn't quite got there yet. Assuming we can only get raises at the beginning of each year, which makes sense in terms of our sequence issue, we'd have to say in the 4th year, we'd have to round up, even though it's a small decimal. Okay, last one, part D. What is the total amount she'll earn in 8 years? Keyword there, total. That's a sum. That's an S question. So S8. The question we have to ask ourselves is, can I use the shortcut, or do I need the long version? So do I know the last term, the 8th term, if you will? And at the beginning, we were told that, right? We were told 56,000 was the 8th term, and we were told the first term, so we can use our shortcut. Okay. So 46,850, first term, and last term we said was 56,650. And we can add those together to times it by 4, and we should get a total of $414,000 over the course of those 8 years. Okay, so that's an arithmetic series. It's an extension of what we did yesterday. We're just trying to add together the parts and pieces of a sequence. Okay, some questions we should try. That'll be it for sequences. For arithmetic things, we'll move on to a new idea tomorrow called a geometric sequence.